Hi class, today we are going to teach chapter 2. The topic of this lesson is types and methods of data transmission. Suppose there is a network connecting multiple computers, and today Alice wants to send data to Cindy. How can the network know whom to send the data to? The answer is we can use the packet. First, we can put the data in a packet and fill in some information. Then the network will know where to send the data. Okay, let's talk about packets first. A packet has 3 parts. The first part is the header. The second part is the payload. The third part is the trailer. The packet header is like the envelope and the beginning of a letter. The packet header consists of 4 information. The first is the IP address of the receiving device, or you can call it the destination. Just like sending an email, you need to write the email address of the receiver. The second is the IP address of sending device, or you can call it the source. Just like writing an email, you need to introduce who you are. The third is the sequence number of the packet. Imagine you are sending a series of letters to your friend. To make sure your friend reads them in the right order, you number each letter. This number helps the receiving device assemble packets in order. Just like your friend could read this letter in order according the sequence number. For the packet size, it shows how big the packet is. It helps the receiving device check whether the packet loads some data during transformation. The payload contains the actual data of the packet, just like the main body of a letter. And this is usually about 64 kilobytes. For the packet trailer, this is like the end of the packet. It contains a signal of the end and an error checking method, such as CRCS. For the signal of the end of the packet, its job is to signal the end of the packet to the receiving device. It's just like to inform the receiving device, oh, this is the end of the data you need to read. It helps receiving device know when to stop looking for more data in that packet. After we talk about the structure of packets, now we are going to talk about how the packets are transmitted. That's packet switching. Packet switching is the way to transmit data we use now. The packet switching could be like this, such as we want to transmit a data from router A to router B, and The router 1 to router 10 represents the routers in the network between router A and router B. For the packet switching, it has the following characteristics. First, each packet may have a different path to the destination. Second, routers will determine the route of each packet. It means that routers will calculate the pace of each packet. Third, routing selection depends on the number of packets waiting to be processed at each node. It means that routers will try to transmit data to the route with fewer packets. Fourth, each packet will choose the shortest possible pace that is available, and packets may change the order when they reach the destination. If today we want to send a message, "I miss you," to a friend by packet switching, the first step is to divide the data into small packets. So we will separate the sentence to 3 parts. Then we will transmit the data from computer A to router A. Then router A will send the data through the routers to router B. Then your friend can get 3 packets from computer B. Although the order of packets has changed, your friend still can get the right data by the sequence number here. But why not just connect router A and B by one line? Why does the data need to go through so much routers? The first reason is if router A and B are just connected by one line. If this line breaks, then the router A and B cannot communicate anymore. If router A needs to communicate with thousands of routers, then we will need to build a line between router A and each routers. It will cost a lot of resources. Here's all the benefits of packet switching. First, there is no need to tie up a single communication line. It means that we don't need to build a line between each router, just like this one. Also, it is possible to overcome failed, busy, or faulty lines by simply rerouting packets. It means that router can change the path of each packet to prevent those problems. By the way, a high data transmission rate is possible because we can transmit data through different routers at the same time. However, it still has some drawbacks. First, packets may lost and need to be resent because data may go through several routers and get lost on the way. Second, this method is more error-prone in real-time streaming. Third, there is a delay at time destination while the packets are being reordered. Okay, now we are going to introduce a method called hopping. Hopping is a way to resolve the problem that packets may lost and need to be resent. In this method, a hop number is added to the header of each packet, just like this one. We add 10 as the hop number to the header of this packet. Then the hop number is reduced by 1 every time it leaves a router. In this case, the hop number is started by 10. Then when this packet leaves router A, the hop number will become 9. And when the packet leaves router B, then the hop number will become 8. And how's going on when the hop number reaches 0? When the hop number reaches 0 and the packet does not reach its destination, then the packet will be deleted when it reaches the next router. It's just like this. Then the next router will send a resend request back to the sender. So when the packets go from router K to router L and the hop number is 0 when this packet is on router K, then when this packet go to router L, the router L will discard this packet and send a request that we need to resend this packet. Okay, this is today's lesson. Thanks. Bye bye.